Hey guys, hope you guys, all are able to gain some good information from the distribution protection presentation and homework and lab. We'll take a little time to go over the answers here from the homework. Um, you guys, for the part, did fairly well. There seemed to be, a few misunderstandings of what exactly I was looking for. But yeah, we can go over those now. So the first one is we were looking for 1.25 to 3 times um, the maximum feeder load current. And you'd find that in section 6.11. Um, I actually, I was seeing 1.5. Actually saw that I had an outdated version of the standard. So um, you guys got the up-to-date one, and actually just updated mine as well. So thanks for it's allowing me to realize that. Um, for number two, um, so we wanted to set the 50p pickup to 125% of the maximum phase current at the closest downstream device. So here we can see the maximum phase current at the closest device was 1100 amps. So take that 1100 amps, multiply it times 125%, and divide it by the CTR, which was 240, and that'll give us our 50p pickup. Um, I used 50p1p. It's the name of the setting that you would actually put it to. I didn't change out the snips here. Um, for the ground, very similar approach, except we're going to use 9,000 amps because our maximum ground fault at the closest device was 9,000 amps. So that one comes out to 46.8. I think almost everybody gave me curves for these two responses. I actually didn't really need curves at this point. I guess for the whole homework, I really only needed two curves: a phase curve and a ground curve. The settings kind of work together, within the curve to create a characteristic. Um, but if you're able to give me these numbers, we were good with that. So number four, please determine the range of acceptable 51p pickup settings. Assume the minimum pickup is 200% of the peak load current and the max pickup is 50% of the minimum phase current. So I was looking for a minimum and maximum allowable setting, based on this criteria. So the minimum was 200% of the peak load, which, again, we got up here. We got peak load of 280 amps, and then our minimum phase fault was 1800 amps. So those drove these calculations. Again, the settings are in amps secondary, so you divide by the CTR. So number four is really supposed to just give us an acceptable range. When we come down to number five, we're looking for us to kind of refine that phase pickup, and then from there, define a time dial that would also work. So when you come down to number five, really any number between 2.33 and 3.75 would be acceptable. You pick a number from the acceptable, range, and then you can tweak your time dial as needed. So we can see, I set mine here. There's more than one acceptable answer, but this is the one that I had. I chose a pickup of 3, kind of right in the middle there. It's a clean number, but like I said, 3.5 would have been fine, and 2.5 would have been fine. Anywhere in that range would have been fine. But for this example, I picked 3. And then I chose my time dial as 3.65. Um, I was looking for a time difference greater than 120 milliseconds at the phase fault at the fuse. So we did have to change that to 1100 amps. So at 1100 amps, my fuse would operate in 0.056 seconds. My relay would operate in 0.177 seconds. And my time difference would be 121 milliseconds. And then also my total clear time for my fuse was 0.056 seconds. If I multiply that times 1.3, I get a number that I don't know off the top of my head, but 1.77 is larger than that number. Just kind of eyeballing it. Some other things to note on here. We grabbed our CTR from the question above. I think pretty much everyone just left the curve as U4. I think that's how I gave you the spreadsheet. But U4 is what you would want to coordinate with a fuse. We went over the time dial. The 50 pickup I just pulled from up here, and then we didn't have any need for a delay on this one. So for number 6, a pretty similar process just for the ground overcurrents. This is our acceptable range for this one, kind of is laid out from the, the criteria in the question. This time the minimum ground fault current was 1600 amps, and we only had to do 30% of the peak load because we only had to overcome the imbalance. So similar down on question 7. We were really looking for a pickup anywhere in this range, anywhere between 0.36 and 2.2 for the most part would be acceptable. This one was a little bit more tricky. We still wanted to make sure that our time difference was more than 120 milliseconds and that our relay operate time was more than 130% of the fuse total clear time. But we had the additional criteria that we needed the 51G curve to intersect the fuse at 20 seconds or greater. The reason we need that is because fuses need to be set above peak load for whatever load that they're carrying, but ground overcurrent elements do not. They can be set to a percentage of the peak load because they really only need to overcome the imbalance or what's flowing on the neutral, which should be 0 on a a perfectly balanced system. So on this one, we actually saw that if I bumped that time dial up to 15, which is the maximum setting of the 451, I would actually need to increase the pickup a bit more. So in this situation, the pickup had to be at least higher than 1.4 in order for us to meet that criteria of greater than 20 seconds. But yeah, we can kind of zoom in there. The spreadsheet didn't tell you this automatically. You kind of had to eyeball it. Aspen, you could put a time difference slider on there. But we can see here this intersection happens at about, if that's 10 seconds, this is 20 seconds. I'd call that maybe 28 seconds, somewhere in there. But that's how you would set that one. Again, I took the 50 setting from up above, right here, 46.88. And I plugged that in. So yeah, that's the answer for number 7. Number 8, for the 51P pickup above, let's say we had to make sure the pickup was at least 400% of normal peak load to overcome cold load pickup. Please specify a pickup for the cold load pickup. If you don't want to alter the pickup and time dial selected, how may you alter the settings in questions 2.7 to account for this? Um, so um, to calculate the cold load pickup, it was just 400% of the peak load. That got us to our 4.67. And then I was really looking for, the explanation that we wanted cold load pickup to be active um, right after the breaker closed. So any type of mention of the breaker closing would have been acceptable for that. I'm going back through the lecture to show that. Yep, yeah, the cold load pickup example that we had on the homework or on the lecture. Um, yep. Yep. So we wouldn't want to trip with our cold load pickup. We would want to feed it into the torque equation, where we can see this happening here, where the cold load pickup would be activated, right after the breaker closed, and then deactivated um, after either a period of time or once the cold load went away and the current dropped down um, to a more normal level. So for number 9, we have the following breaker duty on our nameplate. The distribution engineer has selected a reclosing time with 3 reclose attempts and open intervals of 5, 10, 20 seconds. Would these settings work and why? So these will not work. Our first reclose attempt would be fine. Our 5 seconds is greater than our 0.3 seconds. It's the second reclose attempt that would not work. 10 seconds is less than 15 seconds. Our breaker would not have time, to reset itself mechanically and thermally, to reclose. And then for number 10, let's say you are on a bus feeding 2 distribution lines. The other distribution line, not the one that we just set, is going to have 4 MVA of solar installed on it with a Y-grounded high side delta, low side GSU. Give one example of how this may affect our settings. So that would increase the fault magnitude on your line, both phase and ground. So we would have to reevaluate our 50 settings to make sure that we didn't overreach other protection. And then also, breakers have interrupting ratings. We may want to check the interrupting ratings on our breaker for that increased fault magnitude. So yeah, that's the homework. If you guys have any further questions on it, I have my email that I believe I put on the distribution line protection lecture right here. Thanks again for having me. I wish you guys the best of luck. You know, moving forward at UMaine, and as you guys join industry. So thanks again. Bye.